Today I want to present regarding on structure study on the use of defective hydraulic cylinder. This presentation will be in this order, and then contents like this: in introduction and experiment and the result and conclusion. In this study, technology for manufacturing the hydraulic cylinder extracted from the drilling machine was developed by analyzed failure. Research method, replacement and repair parts were classified. Through the failure analysis, the section criteria were again presented by matching the theory and application criteria for replacement parts to the product. Repair parts were classified into discarded parts and partial repair, and discarded parts were determined to be non-repairable based on their appearance, and repaired parts were repaired. In addition, hydraulic cylinder test device were developed to present reliable manufacturing standards, and the leakage amount of cylinder were measured based on this test device. The cylinder resembled by repair and replacement of parts were tested again in accordance with the KS 4038 to confirm the quality as the manufacturing product. Through the study, reasonable judgment standard for industrial sites were prepared by suggesting the manufacturing standard at the level of simple recycling and minimum quality standard. Recently, due to mass production and mass consumption in industrial society, global warming is induced not only by depletion of finite resources, but also by continuous use of fossil fuels, thereby rapidly deteriorating the global environment. Therefore, foreign countries are leading the efforts to solve the problem technically through source circulation. In Europe, the waste vehicle disposal directive have been enforced, requiring producers to achieve at least 85% recycle of their waste by weight annually, including reusing and recycling rate of at least 80% by weight. Since January 26 from January, the standards were strengthened to 85% and 9%, respectively. The EU's waste vehicle disposal guideline restrict the use of hazardous substances to prove the recycling of waste, and the use of for heavy metals such as mercury and the lead, cadmium, and the hexa variant chromium have been banned in automobile launches and January 2003. As of April 2021, Korea owns about 24.5 million automobiles and products, produce 4.35 million vehicles annually in Korea. For this reason, considering the environment of the domestic automobile industry was active, measures were required for automobile related environment regulations in developed countries. However, the registration status of domestic construction equipment is 518,000 units, and about 10,000 units are registered every year. However, there is no guidance for disposal of waste construction equipment in Korea. As the Act on the Resources Circulation of Electrical and Electronic Equipment and the Vehicles was published as a law. Although this law requires the recycling of the scrap cars can be observed at 95%. In reality, it is at the level of 90%. The areas of technology and standard and the organization related to the remanufacturing of construction machinery introduced the construction machinery. Manufacturing tends in the trend in the construction equipment industry status and the standardization trend. After that, the standard testing method of the manufactured hydraulic cylinders for excavators and quality certification standard for the manufactured hydraulic cylinders for excavators were established. The test method for the remanufactured hydraulic cylinder for excavator is based on the test method specified in KSI 4038 with related speed of 1.5 meter per second or less. Okay. And then let's some kind of stop here. Skip. As a general rule, before the proceeding with the test, the appearance of hydraulic cylinder should be good. There should be no unknown qualities such as breakage and bending and torsion, etc. So it should not affect other performance. The hydraulic fluid quality requirements were selected according to the standard, and these guys were used as a hydraulic fluid. This kind of shows the experimental method I did in this way. So one is a minimum working pressure test, and the second starting pressure test, the third internal leaking test. This is kind of standard. We have to understand this kind of the inner level for the cases. This is kind of regulation. So this is different inner diameter, and the leakage has to be in there, and the inner diameter, and this one is like 3 is like this, and the inner diameter like this, and then 3, 40, 50, 60, 80 is like this. This has to be leakage within this leakage, and then it's okay. But more than this, that has to be discarded. We have to throw away. So we have to some kind of reactions has to be. So this is some kind of regulations you have to understand. Let's do some research on this. This shows some kind of graph like this, and then this figure shows some kind of leakage tests. Leakage test or leakage test is with time, and like this, and this shows the mass flow, and this shows the pressurized pressure, pressurized pressure at time. So this is just we mentioned about. Okay, so this is leakage with more than this, and it has to be we have to throw away. And this is a leakage for test through the static pressure. The static pressure like this, and then this is mass for this is pressure. For this case is like. And let's look at these figures. This is for there is some cylinder inside. There is some cushion release inside. We have to understand the cushion release. But cylinder is increased linearly and increased with the time. The maximum mass flow rate increased, and suddenly decreased in the region of the cushion region due to the. So we have to carefully understand this what kind of condition is this. Okay. Okay, here is the mass flow rate after cushion region. There is some mass flow decreased, and this is increased in this way. And another one is like this. This one shows the figure 9. Figure 9 shows this is for the figure 9 graph. Figure 9 is a graph analyzing the flow length curve in the buffer section when the normal cylinder is torsioned. Red one, this is the red one, is the test graph, and the blue one is applied average error. This is testing this error. Error range. Okay. After testing cylinder, another cylinder with the same specification, it is possible to check whether cylinder, piston, and the buffer ring are defective according to the flow rate curve of the same similar shape through flow analysis in the buffer section. Let's make some like this again. Look at the previous one is like this, but some defective, we obviously we can understand like this one. Look at this blue one, red one. Yeah, there is some differences in there. So we can see. Figure 10 is the result of analyzing the flow rate of buffer section during elongation after assembling the piston and the buffering ring inverse to the cylinder of the same specification. And then it can be confirmed by there is a defective there is defect. This is right something like this. So from this kind of diagram, this shows how cylinder is defective or not. Or we can discard or reusable. We can. This is kind of guidance. We can whether we can throw away or we can use it. Okay. This figure shows the result of the testing tension, and after assembling the same length without preceding the buffer ring on the cylinder of the same specification. This figure shows the result of the experiment after cutting and assembling buffering in the buffer zone at the end of the piston. And it can be seen that there are assembly, manufacturing defect, and the piston defect. Okay. And finally, I show some kind of thing. This kind of thing here is this kind of shows some kind of thing is the flow or curve for the normal. This is normal cases of the normal cylinder buffer section. But obviously, you can see there's some defective. Obviously we can understand like this. There's some variance over there. Let's make some conclusions. In this study, the test apparatus of the manufactured high hydraulic cylinder for construction machinery were tested and analyzed in accordance with the Lima 304 and KSI 4038, and 95% of the performance compared to the new product were confirmed. Through this durability, life of manufactured hydraulic cylinder were predicted, and the following conclusion were made in this way. First, the test device was developed based on the pressure 27 or 45 megapascals of the hydraulic pump of the 30-ton excavator, and 70 types of the measured hydraulic cylinder were tested and analyzed. The reliability of the tested equipment was increased by designing and manufacturing oil tank, accumulator, hydraulic pump, and the power unit according to the standard. It's the result of analyzing 70 manufactured hydraulic cylinder using the developed test device, the performance of 95% compared to the accepted standard were confirmed. Considering above results, it is possible to check the quality of manufactured hydro cylinder product by packing section and testing using a test device, the technical guidance and the method to secure reliability of the manufactured hydro cylinder.